Hello, we from Group A, and our group project title is the production of polyethylene. And before we start the presentation, I would like to introduce ourselves. My name is Aidil, and you can call me Haidar. First of all, we go into the introduction, which is the polyethylene is the common product that we use daily. For example, bottle plastic and plastic bag. And then the polyethylene is produced in a large scale, which is this type was the most popular polymer material that we can see in our environment. And then polyethylene also known as the 5th largest production and consumption of the synthetic resin in the world, because it was versatility, durability, and low cost. There are several types of polyethylene. First one, the low density polyethylene, which is LDPA, that we use commonly in packaging materials such as a plastic bag and a film wrap. Second one, the high density polyethylene, which is HDPE, that usually used in products like a milk jar, detergent bottle, and water pipes. The third one is the linear low density polyethylene, which is known as the LLDPE, that suitable for applications such as the stretch film and the plastic bag. Next, we move to the pros and cons of this production of polyethylene. First, the pros of this production is the low cost, good electric insulator, good heat resistant properties, and water resistant and durable. And the cons of this production is it takes a long time to decomposition, and the dispose using incineration need a large amount of the energy.
Hello and Assalamualaikum. My name is Akmal Rizal, and today I will explain about the block flow diagram of our process. So for the first one, the raw material goes into a reactor. This is the initial chemical reaction take place to form an intermediate compounds, and then it goes into a rundown reactor. This might involve a secondary reaction or stabilization of the intermediate products before further processing. After that, it goes into a centrifuge. The centrifuge separate the mixture based on the density, and then it goes into a extruder. The extruder is to shape the material into pellets or specific forms, and then it goes to blending silo. This step ensure a uniformity of the final products by blending the different batches or grades of material. And finally, it goes into a storage silo. The storage silo serves as a holding area for the finished product, which is now a high density polyethylene.
Okay, so now I will explain more detail of each of the component of the process. So the first component is reactor. In the production of polyethylene, the reactor is essential for facilitating the polymerization of ethylene monomers, managing heat, ensuring proper mixing, controlling molecular weight, and maintaining safe and efficient operation. The second component is a rundown reactor. It serves to process and stabilize the polymer product after the main polymerization reactor. It helps in cooling, pressure reduction, and sometimes further polymer modification or degassing, ensuring that the polyethylene is in the right state for downstream process and final product formation. The third one is centrifuge. It used to separate solid polymer particles from the liquid medium, such as solvents or unreacted monomers. This separation is crucial for purifying the polymer and preparing it for further processing steps, such as drying and pelletizing. Next is extruder. It used to melt, mix, and shape the polymer. The extruder homogenize the polymer melt remove any remaining volatiles, and then force the molten polyethylene through a die to form pellets, films, sheets, or other desired shapes for final product use. And then we have blending silo. It used to homogenize the polymer pellets by mixing them thoroughly. This ensures the consistent quality and uniform properties in the final product by evening out any variation in the polymer produced during different batches or production runs. And last, we have a storage silo used to store the polymer pellets after they have been processed and blended. It ensures to a continuous supply of material for packaging and distributing while protecting the pellet from contamination and environmental factors. Okay.
Okay, so move to the process. The first process is ethylene feed preparation. Ethylene, which is C2H4, is obtained from natural gas or crude oil refining. It undergoes purification to remove impurities like water and sulfur compound. The purified ethylene is compressed to around 1500 bar. The second process is hypercompression. A hypercompressor further increases the pressure to 2000 bar. This compensates for pressure loss in the recycled stream and outlet feeds. The third process is polymerization. The heart of the process is the plug flow diagram, PFR. Inside the cooling jacket, ethylene reacts to form polyethylene. The reaction is highly exothermic, which is release heat. The temperature for the operation is around 70 degrees Celsius. But the polymerization forms a long chain of repeating ethylene unit. The next process is polymer separation. The reactor effluent contains unreacted ethylene, polymer solid, and catalyst residues. The separator removes unreacted ethylene, which is recycled back to the reactor. Polymer solid settle to the bottom and are sent to an extruder. The last process is extrusion and forming. The polymer mat is extruded through a die to form pellet, sheet, or other shapes. These pellets can be used directly or further processed into products like film, pipes, and container.
And for the last one is a conclusion. For our team, in conclusion, polyethylene production remains an important industry process with an important application. And future work should focus more on improving a sustainable, reducing environmental impact, and increase in economic efficiency to ensure the continued success and adaptability of polyethylene production in rapidly growing market. That's all from our team, and thank you.
So, before we end, we want to show you an example of the making of polyethylene bags.